Binary representation in digital systems. 1. Introduction to binary code. All digital systems, including computers, smartphones, and gaming consoles, store and process data using binary code, a system that represents information using only zeros and ones. Why do digital systems use binary? Computers use electronic circuits that operate with two states, ON, 1, and OFF, 0. Binary is a simple and efficient way to represent data in electronic systems. Every piece of data, text, images, audio, and numbers is converted into a unique binary format for storage and processing. Example, when you type the letter A on a keyboard, the computer converts it into binary, e.g., 010001 in ASCII code. 2. How digital systems convert data to binary. Digital systems use binary encoding methods to represent different types of data. A. Text representation in binary, character encoding. Text is stored using binary codes that correspond to letters and symbols. The most common encoding standards are ASCII, American Standard Code for Information Interchange, uses 7 or 8 bits per character. Unicode, UTF-8, UTF-16, supports multiple languages and special symbols. Example, the word hello in ASCII binary. H01001000, E01000101, L01001100, L01001100, O01001111. B. Image representation in binary, pixels and bit depth. Digital images are made up of tiny squares called pixels. Each pixel has a color value stored in binary. Black and white images use 1 bit per pixel, 0 equals black, 1 equals white. Grayscale images use 8 bits per pixel, shades of gray from 000 to 11111111. Color images use 24 bits per pixel, red, green, and blue, RGB. Example, a black and white pixel image of a smiley face might be stored as copy edit 0001100, 0010010, 010010, 100001, 01111110, where 0 equals black and 1 equals white pixels. C. Audio representation in binary, sampling and bit rate. Sound waves are continuous, analog, but digital systems store them as discrete binary values using a process called sampling. Sampling rate, the number of times per second a sound wave is measured, e.g., 44,100 samples per second for CD quality audio. Bit depth, the number of bits used per sample, e.g., 16-bit, 24-bit audio for better sound quality. Example, CD quality audio, 44.1 kHz, 16-bit, equals 44,100 samples per second, with each sample stored as a 16-bit binary number. 3. Binary for efficient integer representation and calculations. Digital systems also use binary to perform mathematical operations and store numbers efficiently. A. Decimal versus binary number system. Decimal, base, 10 used by humans, consists of digits 0 to 9. Binary, base, 2 used by computers, consists of digits 0 and 1. Decimal. Binary. 0. 0000. 1. 0001. 2. 0010. 3. 0011. 4. 0100. 5. 0101. Example, the decimal number 13 in binary is 1101. B. How computers perform binary addition. Binary addition follows simple rules. 0 plus 0 is equal to 0. 0 plus 1 is equal to 1. 1 plus 0 is equal to 1. 1 plus 1 is equal to 10, carry 1. Example, binary addition of 5, 0101 plus 3, 0011. 0101, 5 in binary. Plus 0011, 3 in binary. 1008 in binary. This is how computers perform calculations using only zeros and ones. 4. Role of logic gates in binary processing. Computers use logic gates to process binary operations. Logic gates perform simple calculations that enable complex processing in CPUs. Logic gate. Function equal to 1. Example, binary input-output. And outputs 1 if both inputs are 1. 1 and 1 1. OR. Outputs 1 if at least one input is 1. 1 or 0 1. Not. Inverts the input, 0 becomes 1, and vice versa. Not 1 0. Example, if a security system checks both fingerprint and password input before unlocking, it uses an AND gate. 5. Practical applications of binary representation. A. Storing and transmitting data efficiently. Text messages, SMS, use binary to send characters via networks. Images and videos are compressed into binary formats, JPEG, MP4, for storage. Audio files, MP3, WAV, store sound waves in binary. B. Binary in everyday technology. QR codes and barcodes encoded in binary for quick scanning. Computers and smartphones convert user input into binary for processing. Digital clocks and calculators perform timekeeping and calculations in binary. Example, when you take a selfie, your phone converts the image into a binary file, JPEG, before saving it. Summary of key takeaways. All digital data is stored and processed in binary, zeros and ones. Text, images, and audio are converted into binary formats for storage and manipulation. Binary numbers allow efficient integer representation and calculations. Logic gates process binary operations, enabling complex computing. Binary encoding is used in everyday applications like QR codes, images, and digital communication.